We have this 4.6 properties of logs. Today we're going to talk about expanding logs, and tomorrow we're going to turn right back around and go backwards, which should be really easy once you get today's lesson. Okay? 3 rules. This goes for today and tomorrow. You've got properties for products. If I start off and I'm multiplying things together, for example, here you've got log base b of m times n.
So it's pretty much exactly like exponents.
Yeah, it's exactly what it is. So when I'm multiplying, I'm really adding. So if you think about your exponents, I'm pulling them back apart. Okay? A good observation. That's B. These are all letters. Okay? Quotient property says if you're dividing, you're subtracting. Okay? This is the one that's a little bit different. The power property says when you've got something raised to a power, and I've mentioned this in class before now, that exponent can come right out in front of the log. And you can rewrite it as n times log base b of m. Okay? The challenging part here is I'm going to throw a whole bunch of things together and mix it all up and ask you to apply these whenever it's necessary. Sometimes you're not going to be able to apply any of them, and you're done. It's just not reducible, not expandable. Sometimes you're only going to be able to apply certain ones. And you're going to have to know exactly when it applies, when it doesn't apply. On the screen, you have a logarithm, and it has a log of something equal to the log of something else. Okay, look at the other equation. You have log of x plus log of x plus 3 equals 1. I want you to notice the differences in the equations. One of them is log equals log, and that's it. Is it possible for me to get the other side to be log equals log? Can I get this one? Can I get this side to be just log equals log of something?
Yes. No.
Is it possible without any extra parts?
Yes.
No.
With extra parts. I don't know if anything possible.
Let's be serious for a minute. It's not possible. This one, listen, Marquise, sit up. This one is easier. Do you remember how we said if we can get the same base on both sides, I can just let the bases drop and let the equal part of the exponent be equal? This is exactly the same idea. If you can get it to be log of the same base on both sides, what do you think happens? They effectively cancel out, and you're left with just the inside part, and so it looks like this.
I was right.
Shh, pay attention. So what's the answer?
I don't know.
Simplify it.
That's a good question.
X plus 6 equals 4 minus x.
It's -1.
So we're going to add x to both sides, and I'll go ahead and subtract 4 from both sides, and x becomes -1. Write this down. You must check your answers with logarithms. The domain for a log is not all real numbers, and that's all that it matters. Because that means that you have some x's that don't work. There's some x's that if you plug it into your calculator, log of something would give you error. If that's the case, you need to make sure that this value doesn't make that happen. Now, your number, like this is -1, that tells you nothing. -1 may work, it may not work. What depends on is when you plug it back into your equation at the top. Okay? So if we plug this in and just look at it, what's going to happen? Log of what? Yeah. And so you both get log base 8 of 5 equals log base 8 of 5. Which is it doesn't equal 1, but it's the same. It works. So this is good to go. Now, careful. Listen. This is the one that's going to take a little more work. Anybody have a question about the first side? That's the easy version. That one works just like the exponential did. You just drop that one part, you set them equal. Now that can get more or less difficult depending on what's in the log. Look at this part. Shh. let me give you the tip of how to do these. The tip is whenever you have several logs on one side, not equal to a log itself, but equal to a number, you need to condense them so that you just have one log on one side. If I've got multiple logs on both sides, then condensing them down to as small a value as possible might make it even easier. Sometimes that's not possible, like this one. So we're going to condense one side. So you get this pretty much, right?
That's what I got. I'm lying, but yeah.
What happens is, remember I told you over the weekend, well I didn't tell you over the weekend, but I told you Friday that this is the building blocks to doing what we're going to do next. And this is why you needed to know how to condense and expand. Condensing is more valuable here than expanding because it's one of those things where I need to get it to some log. How do we get rid of, well, what? I'm going to go ahead and multiply through. And so I end up with that. My question is, do you remember how we got rid of the log? Excuse me, I didn't see you there.
That was a line or something.
What do I do?
Exponential.
Good. I need to turn it into exponential form. And so, in order to do that, I actually need to know the base. I didn't write the base. What is the base?
10.
It's 10. Right? So we're going to raise 10 to what power? If I convert it to exponential, what do I get? Say it one more time.
X to the second, x squared plus 3.
Equals what?
1.
No.
Oh,
10. What?
Shh, watch. I take 10, I raise it to the other side power, which is just 1. So I'm going to get 10 equals, 10 to the first power equals the x squared plus 3x. Does that make sense? The base was 10 because if the base isn't written, it's log, it's automatically 10. It's called a common log. That's what your calculator uses, what most of the time we use. So they don't write it. So it's just called a common log. If it's not written, if it's log and there's nothing there, it's always 10. Anybody not quite sure how we got here?
Yeah.
Abby.
All of this. I don't know where you got any of it. Like
Let's go back for a minute.
brackets and then X.
Oh, well, the first part was your homework over the weekend. Condensing. If I'm adding things together.
I never had any brackets in those answers.
Oh, brackets doesn't matter. I could have put parentheses there.
But still, we didn't get this.
Let's do an example like that one. One more time. I took the base, I raised it to the power on the other side. It's equal to what I'm taking the log of. Sit up. Get some water. I'm tired too. It's going to be a long week. After 2 short weeks, it's going to be awful. Tim's handing out Adderall over there. I don't think so. Yeah, whatever. Okay, let's be legal here. Whatever. Once we get here, what happens? Okay. Subtract 10 from both sides. Factor. Ooh, what's factoring? Ooh. What is factoring about? How do I factor that problem?
plus 5 plus 2, 7.
It's going to be 5 and a 2.
Negative 2.
5 and 2. Which one's 5's positive? Why? Perfect. 5's positive because the 3's positive. It's the larger number. It gets the second or the first sign. The last sign's negative. Tells me that they're different signs. Now the question is, do both of them work or not?
No, you have to figure it out.
You tell me. Plug them back into the original problem. Plug it back in and tell me which ones actually work or not.
They can't be negative. Right?
As long as if I plug the number in and it makes what I'm taking the log of negative, it doesn't work. So plug in the positive 2. Okay, go back up to the top. 2, that's good. And 2 plus 2, that's 5. So log of 5 and log of 2, check. They're not, no problems.
Wait, that does not add up together. Two
Yeah.
and 5 does not
It's log of 2 plus the log of 5.
doesn't equal 1.
You sure?
No.
Try it.
Wait, I don't even know what that means.
I don't either. It's okay. What happens? Shh. Kelly, what are we really looking for?
I don't know.
I didn't want you to work it out. Shh. What I wanted you to do was to plug it in and see if you got negative numbers.
Is that bad?
Yeah, you can't have them. For example, look up here. Look. Look on the screen. If I plug in negative 5 right here, it's log of negative 5.
Yeah.
I can stop. That is not allowed. If you get and you plug the number in and it's negative, it tells you that it's not a valid answer.